This is a video description, a narration of the potential of the Crown King gold mine and the Bradshaw Mountain area. Here's Crown King, a little village up in the Bradshaw Mountains of Arizona. Here's the brown roof. Here's the saloon, and you see Main Street's a dirt street. Here's the mall over here. Volunteer fire department. General store. Got a few resorts, a couple cabins, a resort, another one south of town, a couple of other ones spread breakfasts. Up to the mine is up the mountain to the north, about a mile. You see the big scar is the dump, the tailing dump from the mine. Not much material left there, but there is some material there, and it does have some gold in it. A small plant could work that. Here's the Silver King patent. This is originally 20 acres. There's a 2-acre strip here that's not part of this. Goes right through here. This south 2 acres. However, the main adit for the mine was right here, and the red line indicates roughly where the vein is at the surface. You can see it runs down through the center of the patent. It's a 17.5-acre patent. It's actually the Silver King patent, but it was called the Crown King mine, and this patent here is 17.5 acres. The main mine is right on it. Contains 20 million gallons of water, and we believe another 400 feet of ore reserves underneath the existing workings. This is the best mine in the Bradshaw Mountains. It was in the 1880s, 1890s, and after exploring the Bradshaw Mountains, it still is the best mine and the best potential for vast quantities of ore. Right here, and there's a couple more small adits that were, one was about right in here, and there's another one that was right up in here. Now this little road that comes up through here to the top of the property, here I've scratched in and found the vein here, and we got decent assays right there. So the history of the Crown King mine here was the biggest producer in the 1890s up in the Bradshaw. Produced over $1.5 million worth of gold in the 1890s. Gold was pretty cheap about then. It was probably about $16 an ounce. So a lot of gold and silver, actually more silver than gold. Zinc was another money maker for the mine here. So a lot of this was stoped out. So we also have realized that in the wet season, water sometimes will dribble out down here at this lower part of the hill and across the road. And so knowing where the water is there, we know how it's stoped out by how much was excavated out of the mine there. We can calculate the volume of how much water is in the mine here. We calculate we have 20 million gallons of water. Now the water tests roughly neutral for pH, so that indicates that it's not leaching out any heavy metals or arsenics and stuff. It's pretty neutral. It's actually a good mineral water. It's the parts per million, or the total dissolved solids was around 700. So that makes it a mineral water. So a good filter system, just a charcoal filter system, would make decent water there. The arsenic level is way below the national standards. So I've drawn a 3D image of this vein down through that you can see how these veins lay in here. It's calculated a drill rig right here, the neighbor's lot, to drill down straight, almost straight down, about 75 degrees down, and intersect the vein, and a couple other spots up to the north and to the bottom of where this was worked. The existing workings go down 650 feet, at least the shaft does. We don't know for sure how much stoping was done that deep. These ore chutes, which are the mineralized zones in these veins, and you'll see this in my section, the yellow indicates the mineralized zone in this vein. Some people think the whole vein is where the ore is. It's concentrated in chutes where it was obviously fed from all this hot liquid when this was mineralized. Now here's a section of the Crown King. Here's the vein. It dips to 70 degrees to the west, which is off to this direction, here to the left. Surface of the ground is up here. It's in a bit of a valley, comes back up. Drill rig is on the west side, on a hillside. We have to get far enough over to the west in order to intersect these veins. So we've calculated the distance and depth to this area. If we put some animation to this, you'll be able to see a good picture of what's going on here. See, the ore chutes are in the yellow. The magenta is still vein material, but it's not as highly mineralized. It's quartz and minerals. And here on the back view, you can see the brown is the stoped out area. That's the mine area. That's been mined. So obviously there's a lot more to be had there. We believe these sections that are on their side are about 1,000 feet deep. So if they mined about 600 feet, there's another 400 feet of ore below the existing mine. Now this mine here also, you can see that if a lot of that was stoped out and it's 2/3 full of water, that's a lot of water. And we calculated it being 20 million gallons of water. So that's an asset right there to have. If any other mining operations are going to take place in this area, they're going to need lots of water, and the Crown King mine has it. Not to mention a lot of gold and silver. So here are the drill targets calculated, the length and distance for pricing to get to drill this, to drill below this existing mined area. The ore chutes are really the key thing to understanding these gold mines and this mineralization in the Bradshaws and in Arizona and Nevada. Basically, I think anywhere around the Pacific and around the Pacific, the subduction of the oceanic plates subducting underneath the continental plates, one here is North America obviously, was the source of all this mineralization and volcanism. So with that in mind, I'm going to go through and talk about how this mineralization got here. Why it's so important to know how it got here is we can then understand where this mineralization, what direction it's at. They went down 650 feet. Is there more down below? Is always the question. One thing in the geology books about the Bradshaw area, the Crown King area, is that they have noticed that the ore chutes pitch to the north, which means there's an ore chute in this vein that's a mineralized zone that points north, in the north direction. This vein here strikes, which means the direction it lays on the surface, it strikes to the northeast. The ore chute pitches to the north at a certain degree from the surface, from level, say 30 degrees, 40 degrees. That's key information. All this was mineralized when it was these these thrust faults, or these faults that this mineralization is in, these cracks, were horizontal at one time. It was like a strata of sedimentary material. The mineralization pushed through that horizontal spot, and since then it's been turned on its side, 70 degrees almost on its side. And here I'll show you the generalized diagram of what happened with the structure of these rocks around here. This is in a schistose rock, a schist. It's called Yavapai schist. It's a metasedimentary rock that was formed at the bottom of the ocean in 1800 million years ago. It's very old stuff. Now the mineralization I don't believe happened to then, but all the sediments were metamorphosed. The ore chute direction is key to understanding this area. Once we know how the direction of this rock was laying when it was mineralized is key. Once you acknowledge that the fact that this was horizontal, all these veins, that red line there, the structure of the vein, it wasn't down straight in the ground, it was horizontal when it was mineralized. So knowing that, and most experts agree that it was horizontal. Some still believe that it came up from the bottom of the ocean and black smokers, but those are promotional gimmicks to try new ways to get people excited about these old gold mines. Here you can see the fluid rising up through the crust, gets caught by this horizontal thrust fault, and obviously fluid follows the path of least resistance. So this mineralization goes out horizontally. Here is the center, the volcanic center, the vent through the crust. This vent here, and this area, this drawing only indicates one side. This obviously goes in other directions all the way around here at the perimeter. This area here is our specific vent for the Crown King mine. As these fingers of fluid went out, you can see, and here I've noted existing mines that we know the type of mineralization went through here. The DeSoto was mainly a copper mine. We believe the Thundercloud 13 is. The Billy Boy, we can see copper. So this feeder right here, I call them, had more copper mineralization than gold. This one through here runs through some claims that we have, we've done some testing on, and those line up, and the material seems to look the same. This claim here looks the same as this one here. This one right here runs through the Peck mine, which is a famous silver mine, and the Swastika is as well. I'll show some sections of that'll indicate how this basically here is an ore chute, a mineralized zone, this feeder. So we're going to see some geophysics of this area right here that'll show this vertical trend. Of course, it's kicked on its side now. It's not horizontal anymore. But we'll see that in these sections I've drawn. Here's the Crown King mine, the one I'm talking about right now. And you can see how this ore chute pitches to the north. Goes up through here. That makes perfect sense. I'll show a map of the overview of the whole area. And some of the key mines in the area had good descriptions of the ore chutes and the geology structure. And so when we map those out, the ore chutes all point to this direction. This is the common intersection point. Also, our geophysics points to the same point. Here's the map of with the plotting of the ore chutes. So there's a mine. Here's the Crown King mine down here. We have the ore chutes plotted. They pitch to the north. You lay them on their side, these veins on their side, and then create a bearing off the ore chute. That's what we're laying out here. So the Crown King mine is heading this way. The Gladiator mine is similar in the same direction. The Peck, the Silver Prince, or the Swastika those chutes are pretty much straight down from the direction of the strike of the veins, and those point in the same direction. Mines to the north of this area, those pitch to the south, and that's documented well in old USGS documentation in Lindgren's book. He was well known and did very good research in the area in the 1920s. So when we lay out these ore chute pitches, they had the same direction. The McCabe mine up here heads this direction. The Sutter mine heads south and east. So the more information, the more mines you get, this intersection starts taking place, and you start seeing a spot to look. So this brown area right here is a granodiorite pluton. It's called the Brady Butte granodiorite. It's kind of a well-known geological item that has been described a lot over the years by geologists. I'm showing this for a reason, because this is kind of like a granite, but it's between the volcanic center and this area here, which is a schist belt. It's a 2-mile wide schist belt that runs through Crown King. And that's the schist metasedimentary material that's on the side now that I talked about. Was horizontal. So this area was horizontal, these thrust faults. This was mineralized. And then the plate tectonics continued to shove things to the east, and these layers got stacked up on each other. Here's a section that shows here's the vent. Mineralization went through. These areas, the Farallon plate is continuing to push east, and all these slabs of schist get shoved onto their side. They get pushed up. Here's another big pluton, the Horse Thief Basin pluton. These aren't drawn to scale, but this kind of indicates what's happening here. The schist got stuck in between there. It's getting shoved up and turned on its side. Here, you can see these slabs are pushing up, and common sense shows that big concrete slabs will get shoved up. One gets shoved up, then the next one, and the next one, and so on and so forth until they're all almost vertical. And this happens pretty much all the metasedimentary schist in the transition zone in Arizona is kind of like this. It's either vertical, sometimes it dips to the east, but most of it's dipping to the west, or some of it's pretty not very steep. It's very shallow. There's some pieces of this that are floating inside these plutons of granite that are almost flat, so indicating that they were protected by these big Precambrian 1800 million year old plutons of granite. They were protected from all this force that was pushed to the right. Now you can see the mineralized zones. Here's the veins, and in our geophysics we see these big areas of a lot of magnetic indicators in our geophysics, and we believe this is that is. When these slabs were getting pushed up there, it was taking a chunk out of this next slab, and so all this stuff is loose, and when the fluids come up through here, it fills those voids, and we see a lot of that material in the old mines. It's all cemented together. Here's some geophysics that shows what's going on. Here's a tabular body, or a vein, that they do the math on and calculate the resistivity to find out that this is a high area metallics. These possibly are these zones right here full of fluids that filled the cracks in all this loose material. The blue is high resistivity or no conductivity, probably granites. Here's some ground geophysics that we did that kind of indicates that same layer about 350 meters down. This layer right here is the conductive zone. The blue is the resistive zone. And you can see down below, it's all mostly blue with some streaks of mineralization. Here's a high conductivity zone here. Here's the vein there. But there's also these other areas. These other areas got mineralization in them as well. And that's from this configuration here where there was mineralization coming through in different areas as these things were getting turned. This indicates that about 900,000 feet down is the edge of these overturned schist slabs, for lack of a better word. So this is our reasoning behind the depth of the Crown King, while the mineralization still continues. Later on, after mineralization has taken place, a rifting or pulling apart of the area started to happen. The Pacific plate started pulling out, extending the southwest North American continent, southwest United States, to the west. So all of a sudden now the direction's changed after a big, long time of nothing happening. The direction changed and the Pacific plate's moving faster than the North American plate is, and it's extending the southwestern part of the United States. So rifting occurs, and these big cracks that form, new plutons of volcanic material come up through, and that's indicated by this green area. So it is a complicated process here, but when you break it down into its parts and timing, sense can be made of it. So these areas and these volcanic centers were pulled apart, extended 25 miles, seems to be the number in the Mojave County area, Nevada. As you get closer to the Colorado Plateau, it becomes less. This area here in the Bradshaw Mountains is in the transition zone. It's not quite in the basin and range area, which was pulled apart the most, but this area was 12 kilometers easy. Some areas not as much because it's more a thicker section of rock and didn't pull apart as much. But here's some air geophysics we did in the area, and I noticed one time that, let me blow this up. These red layers, pink layers, and strips here, basically they're like strips of magnetic signatures. So there's metallics in these red and pink areas. Blue is resistive, like granites and things like that, no metallics. So I noticed, knowing that these at one time were, now they're almost vertical, or so they dipped 70 degrees to the west. They used to be horizontal when it was mineralized. So knowing that, looking at these pieces here, I noticed that the shapes were similar. See, this shape right here has a bit of a head on it, on the end of it, this long column right here. Go farther west, and this is about a mile and a half. You see the same bulb at the end of this long run here. So when you draw a line across it, like we have here, all this stuff is rifted apart, so it's been pulled apart. So if that was all closer together and turned back horizontally, you could see how this was similar to a fan of water coming out of a garden hose, except it's under pressure and it's in a layer, a strata. So it's not quite like a... Here's a longitudinal section, 3 sections out of the air geophysics we did, where I got showed the direction of the ore chute. These run in length with that area, and if you look closely, the red is the metallics, the magnetic signatures. So here it looks like these lines are vertical, and they are. Everything the lines, striations head up and down the page, which is in a vertical direction. These are parallel with those main pink or red columns that I showed you on the air geophysics plan, and you can clearly see that these were horizontal when there was mineralized, that this fluid was flowing. You could see the direction of the flowing, so that again keys into the direction of this fluid flow. These ore chutes have a direction that can be followed. This area here just happens to be straight across, perpendicular, similar to the Peck mine and the Swastika mine, and the ore chutes are vertical there. The Crown King mine is not in this area, and it's farther south, and if we had the same imagery there, we would see a different direction. We would see a vertical, not a vertical line, but a line off at probably a 40-degree direction. So this also supports the documentation, or my thesis, that these ore chutes do have direction. Anyway, so I decided to draw a line to see, just for fun, just to see where that ended up or where that intersected. And this point right here is the same place as the ore chutes indicate. It's this spot right here. So the air geophysics was in this area, and it points to this same spot that these just happen to point to. Now, nothing's perfect in nature, so these lines aren't exactly straight and true. That's obvious for obvious reasons. That fluid is going out and it's snaking around and finding the path of least resistance. Overall, it heads in the right direction. So now I look at satellite imagery of this area, and then I spot the Precambrian, or very old volcanic vent, the crater. You can see the ring. It's round. It's a plateau, a flat area up here in the mountains. It's about 2 miles wide or 2 miles in diameter. And once you realize what it is, it really sticks out. I'll show a picture of that. Here's the intersection point. You can see the flat spot in the indentation here. Not perfectly round, but let's rotate it around here a little bit. Get certain views, you can really make it out. It's a bowl. You can see the perimeter of the old volcano, and this volcano is probably 1,800 million years old. Now, once I noticed that, I went to this area and looked and found all the key ingredients for volcanic activity. A lot different than the rest of the mountains up there. Crown King is up in there. The Peck mines are over here. We have diorite, monzonite, porphyries, a lot of quartz. So there's a lot of fluid flow. Fluid came out of this area. So everything points to this area. There's a heck of a lot of fluid flow here. Diorites that are mineralized. With epidote, there's key signatures of alteration that are key signatures of volcanics. Another thing that's interesting is the assay reports and the 28 mineral analysis of samples in these areas. This and a couple other volcanic centers in Arizona. A few of the key ingredients spike different than the rest of the mineralization in the other areas. So there's certain things that are higher. Aluminums, calcium, strontiums. I've listed in my paper, but certain things spike at these volcanic centers that don't spike in the surrounding areas where there's other mineralization. So Here's a map showing other volcanic centers in Arizona. Blow it up here. In these colored areas, here's the Bradshaws right here. Now, once knowing that this worked, I wanted to see if this worked in other areas, if that same technique for finding these volcanic centers worked. And so I have a lot of information in the Mojave County area, which is the Oatman area, the Music Mountains, Kingman. And so I started reading and researching the mine information, and not every mine has information, key information talks about the ore chute pitch, but I had enough to where I've found intersecting point in this area as well. They didn't line up perfectly until you back up time when this rifting occurred and put all these mountain ridges back to where they used to be when it was mineralized. Everything lines up to a key spot of intersection, and when you go to that satellite imagery, you can see this here is a 6-mile diameter radius that you can see was the volcanic center. So that's very interesting as well. So I started doing that more and more. Here's Baghdad area. I could make out a center for that area. The Jerome area, I know where the volcanic center is that I believe fed the Jerome mine. That's got tests show that the minerals there spike just like or similar to the volcanic center of the Bradshaw Mountain. So those are volcanic centers or vents. There's more in the state, and these the black areas are younger volcanic fields. Here's Flagstaff up in here, over by Springerville, down at the southeast corner of the state, and so on. These have been mapped by, and you can find these on you can Google these on internet now and see where those are. But these areas don't have mineralization. They have a lot of young volcanic activity, but no mineralization. So that's kind of interesting too. The two don't seem to overlap as well. So older volcanic mineralization took care of these areas here. This is the transitions up between the Colorado Plateau and the Basin Range. So that was interesting as well. Here's a map of the Crown King mine, of the workings. And as they mined, and these are all horizontal tunnels, and a lot of these areas have been stoped out or are mined out. These angle lines here indicate where they were mapping the heaviest mineralization or the ore chutes. So you can see that these aren't vertical here. These aren't straight up and down. These are on what they would call a pitch, a north pitch, or they pitch to the north. So the Crown King mine is now offered at $950,000. Terms can be negotiated. So feel free to call us at 623-760-8882.